So by this point, you guys should be familiar with the first quadrant of the unit circle, right? You should know the x and y values of each of those five angles. Uh, but we're just going to review it real quick to make sure we're all on the same track, and then we'll talk about how to use that to apply to all the different quadrants, because that's what the purpose of this is. And we'll talk about how to use the information to figure out the other trig ratios as well. All right. So let's start with filling in the unit circle for the first quadrant. All right. So I'm going to zoom in because I tend to write kind of big. Cool. All right. So when it comes to this point right here in the red, the 0 degrees, which is also known as 0 radians, which I'll abbreviate as 0 rad, I have the coordinate point 1 comma 0. Right. When I get this one over here, I get radical 3 over 2 comma 1 half, which corresponds to the 30 degrees, also known as pi over 6 radians. This one right here in the green is, let's make it green because it's color coding. This one produces radical 2 over 2 comma radical 2 over 2, which corresponds to the 45 degrees, also known as pi over 4 radians. Right. We have the 1 half comma radical 3 over 2, which is the 60 degrees. That corresponds to pi over 3 radians. And lastly, we have 0 comma 1, which is the 90 degrees, also known as pi over 2 rad. Okay? So that's the unit circle that we have, and that's where this all kind of comes back in together. So let's talk about how to use the unit circle. If you notice, each of these angles has produces kind of an x and a y coordinate value, right? So the x value will be the cosine of the angle. The y value will produce the sine of the angle. All right. So automatically, as long as you know the five angles, you have the sine and cosine of each of those angles. The only thing you would have to do is figure out how to take that information and apply it to the other four quadrants. So when I was in school, my teacher taught me this phrase: all students take calculus. Now, I will admit that not all of us took calculus, but most of us did. So let's talk about why that phrase is important, or what it's meant for. We have four quadrants, hence we have four words. We have the A, we have the S, we have the T, and we have the C. So what that means is A would correspond to the first quadrant, and the first quadrant, all trig ratios would have to be positive, right? The x values are positive, so cosine's positive. The sine values are positive, so the y values are positive, so sine is positive. which means that secant and cosecant would also be positive. And we'll talk about how to get the sine right now because we're going to use that in a little bit. All right. So if you know the sine and the cosine, you can use that to get the tangent. And let me show you how. So let's say that we were trying to figure out the the tangent of, what's a good angle? Let's say we're trying to figure out the tangent of pi over 6. Right? Well, if you think about this as a triangle, technically I know the opposite side and I would have the adjacent side. Right? And tangent is the opposite over the adjacent. Well, we said that the opposite is the sine value, so it would be the same as having sine of pi over 6, because that's the value that would give us the 1/2, over the adjacent value. The adjacent value is the x value, which would be the cosine, and in this instance the angle is pi over 6. So it'd be the same as taking those two numbers and dividing them, right? So in this instance, it's y divided by the x, which means it would be 1/2 divided by radical 3 over 2. And now we just simplify this using our knowledge, our fraction of knowledge. Wow. Knowledge of fractions, take 3. Jeez. So 1/2 times the reciprocal of whatever you're dividing by gets us, I'm going to do a little cross simplifying. So 2 divided by 2 is just a 1, so they kind of disappear. So technically I get a 1 left over in their spots anyways. So I would get 1 over radical 3. Rationalizing the denominator gets me radical 3 over 3. And that's how I do it. That's how I get my tangent, right? And this is maybe new to most people, but it's just tangent is equal to the sine divided by the cosine of whatever angle you're using. All right? So, as the video takes me back, notice how I got a positive number from dividing two positive things in the first quadrant. So that's why all trig ratios in the first quadrant are positive. In the second quadrant, here's what I know. Everything in here would have a coordinate point kind of like this. All right. If you notice, the y value is positive. Since the y value refers to sine, that's why the s, that's why I say students, because s for sine, that's what happens in the second quadrant. Everything else would have to be negative. And if you're not sure, you're not convinced, well, try figure out the tangent of one of the ratios that you have, simplify it, and see what you end up with. In the third quadrant, both the x and the y values are negative. So if we think about how the tangent is found by dividing the sine by the cosine, if you're dividing two negative values, your tangent should be positive. That's why the third word is t for tangent. And the last one, we have the fourth quadrant, which has a positive x value and a negative y value. So C for cosine, because the x values are the cosines, that's why we use the word calculus. And that's just what I was taught. Hopefully you guys find a way to memorize it for yourself. if you need to, because when I ask you about the sine and cosine or tangent or whatever trig ratio of a certain angle, you should know the numbers based off that, based off the 5 reference angles, and you should know whether they'll be positive or negative values by remembering that all students take calculus, or just you're talking about the 4 quadrants. All right. The other thing I want to talk about is if we know sine and cosine, we talked about how to get tangent, but we haven't talked about secant or cosecant. So right now would be a good time to revisit it. So let's go. All right. So let's say we have the 6 trig ratios. We have sine, cosine, tangent. Now, because they're ratios, I need to make sure I have an input of an angle for each of these. All right. If we're talking about this in general, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, as we just kind of worked through a couple minutes ago. If we're talking about this in terms of the unit circle, well, we figured out that this really comes out to the y value, this comes out to the x value, and this comes out to the y over x value. Okay? So those are the first 3. So as long as you know x and y, you can use that to get tangent. So now let's bring in the other 3, right? We had cosecant of an angle, which was hypotenuse, over the opposite. Sorry for my sloppy handwriting there. Okay. So if you notice, this is the reciprocal of that. So if I'm using the unit circle, I could just say this is 1 over y. So if I know the y value, I take the reciprocal and I can just get its the cosecant. If I'm talking about secant, my computer cooperates. Well, secant is the hypotenuse divided by the adjacent, which again, not again, but kind of like the cosecant, it's the reciprocal. So this would be found by having 1 over x. If we're talking about cotangent, well, that's just adjacent divided by opposite. In this case, that turns out to be x divided by y. Because again, reciprocals. Right? So as long as I keep that in mind, I can get all 6 trig ratios, as long as I remember how sine can help me produce cosecant, how cosine can help me produce secant, and how tangent can help me produce cotangent. All right. So let's work through an example real quick to show you how to use all the information I'm giving you. All right. So let's say that we have a problem like this. Let's say I am asked to find for the angle, let's make it 7 pi over 6, right? And I'm asked to find sine, cosine, tangent, cosecant, secant, and cotangent. And actually, I don't want to do 7 pi over 6. I decided I want to make it a little more challenging to some that you guys haven't seen yet, or we haven't used in this example yet. So let's make it 4 pi over 3. Sorry for the adjustment. So this angle would have to be in the third quadrant, and I know its reference angle is pi over 3, so I know that typically pi over 3 should produce a 1/2 comma radical 3 over 2. All right, that's the x and the y value. So I know that the sine should be a 1/2. But because it's in the third quadrant, I know it's going to be a negative 1/2. Cosine should be radical 3 over 2, but because it's in the third quadrant, I know that the x value should be negative. Tangent is equal to sine divided by cosine. So the tangent of 4 pi over 3 should be and I have a choice. I can use the two values I have, or I can get the tangent of the reference angle and then just decide if it needs to be positive or negatives. And I'm going to choose the latter option, because as long as I know everything about the first quadrant and I can kind of commit that to memory, then I can just figure out if it needs to be positive or negative later. But for now, that's what I'm going to do. So it's going to be I made an error, didn't I? Yep. Here's what happened. I was so excited to show you the unit circle that I got carried away with the numbers I was using. I made a careless mistake, which you guys would have definitely called me out on later, and I would have appreciated it. I just said sine has to be the y value, and the y value is radical 3 over 2. The cosine is supposed to be the x value, so that should be the 1/2. So when I'm trying to find the tangent of 4 pi over 3, I should take the radical 3 over 2 and divide that by the 1/2, and that will produce radical 3 over 2 multiplied by 2 over 1, because when you divide fractions, you multiply by the reciprocal, and I'm cross-canceling. So 2 divided by 2 goes away, so I end up with a radical 3 over 2. So I'm going to say that tangent should be radical 3. And because it's in the third quadrant, all students take, tangent needs to be positive, so I don't have to make it a negative. Since I know that I'm dealing with cosecant now, cosecant is the reciprocal of sine, so I just take whatever I have for my sine value and flip it. So in this instance, my answer should be negative 2 divided by radical 3, but I would want you to rationalize the denominator. So that would produce negative 2 radical 3 over 3. All right, so that's the answer I would expect you to produce. And all I did was use a reciprocal. Same idea with secant. Secant would be a negative 2 over 1, which again I can just write that as a negative 2, because dividing by 1 doesn't do anything. And cotangent would have to be the reciprocal of tangent. So it'd be 1 over radical 3, which if you rewrite in simplest radical form, once I follow my pattern, 1 over radical 3. This one actually reduces to radical 3 over 3. And that's how you do these kind of problems. You figure out the reference angle, you figure out the quadrant to help you figure out positive and negatives. Once you know the x and the y values, you just write them in. Tangent, you have to do a little bit of work. Same with a cosecant, secant, and cotangent. But hopefully it's not too bad for you. But that's the expectation now.